Welcome to Robominions.in AI interview preparation app. The topic of this video is sum of all nodes in binary tree. Before tracing the code, I would request you to watch this video on a bigger screen like laptop, or at least make your mobile phone screen a full size, horizontally full size, so that you can trace the code along with me. On small screen the code is not clearly visible. Please watch the video on laptop, and also strongly suggest that you should download Robominions.in AI interview preparation app. So after watching this video, you can go to the app, and just by clicking back and next button you can control the code and you can trace the code yourself. By tracing the code yourself, you will have clear understanding, and it also helps in revision. You can do how much ever time you want by just clicking back and next button. You can revise as much time as possible. Okay, and be well prepared before going to the interview or gate exam or any engineering or competitive exams. Okay, so let's come back to the sum of all nodes in binary tree code. And sorry, before going there again, to download this Robominions.in AI app, visit the website robominions.in, download latest version here, and click on download for Windows OS, and then click on download anyway. Okay, yeah. Now let's start the tracing of the code. We have hash include stdi.h, then hash include stdlib.h. Just repeating in every video that this arrow will trace the code. It goes to the line of execution. Whenever you click next, it goes to that point of execution where the code is executing from the as it executes in the compiler. So it does the same execution. So the AI helps us in giving that visualization and provides the breakpoint at each individual step. So now we have binary tree create.h header file included. So this part of the code has already been explained in the video DSA51 creating binary tree. If you haven't watched that video, please watch that video and understand this part of the code. This code will, this function create binary tree will create a binary tree with default values and then return the root. Okay, so that is the function of this create binary tree. Okay, coming back, we have int main, then we have, as I said, we have called create binary tree function, and it has returned the binary tree to the root. Then we have some function to which we have passed the root node address, that is hash 100 has been passed. So that address will be used, so that node will be used. From there we iterate through the entire binary tree and find the total sum of data of all the values of nodes in the binary tree. So let's go to the sum now. Sum of node pointer ITR has received hash 100. So our target node is this one right now. Left sum equal to null 0, right sum equal to 0. ITR not equal to null. Yeah, this ITR is not equal to null, that is true. Left sum equal to sum of ITR left. ITR left is hash 200. Hash 200 is this node. So now the target node is this node. So now again sum is called recursively. So we have left sum equal to 0, right sum equal to 0, ITR not equal to null. Yeah, this node is not equal to null, true. Again left sum is called, sorry, again left sum is calculated with calling sum function, and again we have iteration left. So ITR left is hash 400. Hash 400 is this node. So sum function is called again, left sum equal to 0, right sum equal to 0, ITR not equal to null. This node not equal to null is true. Then we go to left sum equal to sum of ITR left. So ITR left of this node is null. So ITR left is null. So the sum function is called, which has null. Left sum equal to 0, right sum equal to 0. Now if null is not equal to null, so null not equal to null is false. This returns 0 to the left sum. So for this node, left sum equal to 0 right now, and right sum equal to, we have ITR right. So what we do is, sorry, so I'm just going back here, like just clicking back. Okay, so our node here is having left child null and right child null. So right now we are looking at left iteration not equal to null. It is null, it has turned false. So we return 0. So it has returned 0 for the left child. Then we look at the right. So iteration right is null. So we go to the sum function recursive call again. Null not equal to null is false. So this also returns 0. So this right side is also 0. So 0 is returned to the right sum. Now from there we go to the return of left sum plus right sum plus ITR data. So ITR is this node. So data of this node is 13. So 0 plus 0 plus 13. So 13 is returned. Okay. 13 is returned as a left sum. From here it is returned to this node. So left sum is now 13. So green indicates that it has already been summed, already added. Now this 13 is passed as left sum to this node. Now it calls right sum equal to ITR of right. So ITR of right is 500. So 500. So we go to this node now. So sum is called left sum equal to 0, right sum equal to 0. ITR, that is this node not equal to null, is true. Left sum equal to sum of, so we call the function sum of ITR left. ITR left is null, right? ITR left is null. So you go to the sum, left sum equal to 0, right sum equal to 0. Null not equal to null is false. So null not equal to null is false. So this left sum returns 0. Then we go to right sum. So ITR right is also null. So sum of, it calls the sum function. So ITR, so for right side we have null not equal to null false. So returns 0. So both left side and right side is 0. Left sum or right sum is 0 for this node. That is node with the data value 14. Now when I click next, it goes to the return. So you can see left sum is 0, right sum is 0. Iteration data, the data of this node is 14. That is added and this is returned back to this node now. This node function call. So when I click next, it goes to the right sum. The right sum of this node. So right sum equal to 14 for this node. Right sum equal to 14. Then when I click next, it goes to the return of left sum is 13 and right sum is 14 plus 11 of the data, ITR data, that is 11. So this becomes 13 plus 14, 27, 27 plus 11, 38. So this 38 data is sent to root node left sum. When I click next, see, yeah, it goes. Now left sum equal to 38. It has been added. Now the node here is become ITR. Now ITR, so because the recursively we have finished calculating the sum here and it has come back to this function, and here the ITR was pointing to this node. ITR right is hash 300. So it has gone to this node now, hash 300. That is the ITR right. So now here again we calculate all the sum. So sum function is called again. Here ITR is the target, is this node. So ITR not equal to null, this node is not equal to null, true. It comes inside, it does sum of ITR left. So ITR left is hash 600. So this node is hash 600. It goes to the sum function, int left, int right. Then this node is not equal to null, that is true. It goes inside now. Now when it goes inside the function, now ITR of left of this node is null. So ITR left is null. So the sum of null is so the sum function is called, which has a null as an argument. Then left sum equal to 0, right sum equal to 0. Now null not equal to null is false. This returns 0. So for the left side returns 0. So left sum is 0. Then now it goes to the right side. So this node's ITR right is null. So that is sent. So sum of null. So we have left sum equal to 0, right sum equal to 0. If null not equal to null is false, null not equal to null is false, this returns 0. So this returns 0 to the right side. So now right sum equal to 0. Then we return, for this node we return left sum 0 plus right sum 0 plus ITR data is 15. So 0 plus 0 plus 15, 15 data is calculated for this node. So this node has 15 data. So this is returned back to node 12, node data 12. This is part of the left sum of this node. So when I click on next, so left sum equal to 15. Now when it goes to the right sum, so now when we have gone back, the control is gone back to this node, and the iteration of right is node data 16. Iteration of right is node data 16. So now when the sum function is called again, left sum equal to 0, right sum equal to 0. If iteration not equal to null is true, so this node is valid, it is not equal to null, it is true. Now left sum is called on iteration null. So iteration left, sorry, left sum is called on iteration left is null. So goes to the sum function. As ITR is null not equal to null is true. So it returns 0, and then we go to ITR right. So next we calculate ITR right, sum of right. So again ITR not equal to null, ITR is null. So null not equal to null is false, that also returns 0. So left sum is 0, right sum is 0. So this returns left sum 0 plus right sum 0 plus ITR data is 16. So 16 is returned as right sum to this node. So when I click next, it goes to the right sum for this node. Now it is right sum is equal to 16. And when I click next again, now return is left sum is for this node, left sum is 15, right sum is 16, and the iteration data, that is node itself, has data 12. So 15 plus 16 plus 12, 31 plus 12, that is 43. So this side we had 38. Now this side we have 43. When I click next, this will send the data back to this node as a right sum. So right sum is now equal to 43. When I click next, so you can see, so this node in the so we see that left sum is 38, right sum is 43 plus iterator data, ITR data. So ITR data is this node's data, that is 10. So when we calculate this, it would be 38 plus 43 is 81 plus 10 is 91. So 91 data is returned, and you can see sum of all node data in tree is 91. So we have iterated through all the nodes and found the sum. Then it returns from the main function. The time complexity, as we are going through each node, it is order of n. Okay, that is the time complexity. To access the code of this algorithm, you need to click on the button, code button. It's available in the Robominions.in AI interview preparation app. Signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.